Okay guys, so in today's video we are looking at some exam style questions from the AQA AS Pure Maths exam, I believe from the November 2021 series. So these are exam style questions that are appropriate for students here that are in year 12 that are going to be sitting like an AS Pure Maths exam at the end of year 12, and it's also appropriate for obviously the full A-level students so students doing full A-level maths in year 13 as well, and it's also appropriate for the AQA level 2 GCSE further maths as well, and bits of it may also be appropriate for GCSE higher tier, but this is explicitly for like A-level maths students so AS pure maths students. We're going to start with question number 1. State the set of values of x which satisfies the inequality. So I've got a quadratic inequality here. If you look here, it has been factorized. So the roots are as follows. So the roots are x equals 3. So if you set the first bracket equal to 0 and you solve it, and the second bracket is when x is equal to minus 7 halves. If you're not sure where it's come from, I've set each bracket equal to 0 and solved it. Although yes, it says obviously greater than, but I'm trying to obviously find where it crosses on the x-axis for me to actually answer the question if that makes sense. So I'm setting both of these equations equal to 0 and then just obviously solving it solving it separately. So this is obviously knowledge obviously from GCSE maths that you should know how to do. So add 3 to both sides, so you have x is equal to 3. Great, and then this one you subtract 7 and then divide by 2, so you get 2x equals minus 7, and then you get x and then divide 3 by the 2, you get x is equal to minus 7 halves. So it crosses the x-axis at minus 7 halves and 3. So it looks something like this here. It's a positive quadratic, because it's a 2x squared if you expand it out. Which is positive. We want it when when it's above the x-axis. So this is what I call my x-axis. X-axis. When it's above it, well, it's above it here, and it's above it here. So it is above it when x is less than minus 7 halves. And when x is greater than 3. So which of these options is it going to be? Will it be option number 3? It's not that one actually, because so that would obviously be when it's obviously less than 0. And it's not that one there actually, because so it's not that one, it's not that one, and it's not that one. So that's your answer for that. Sorry for actually waffling on quite a bit there, but hopefully it makes sense. So this so this is to do with like solving a quadratic inequality, which again that's also assessed as obviously GCSE higher tier maths so like grade 9 level maths or like grade 9 students this is aimed for. Question number 2, given that y is equal to natural log of 5x, find dy by dx. So your answer, well again it's using the chain rule. So y is equal to log u is equal to 5x, dy by du, so differentiating natural log. Hopefully you're happy with that. If you're not, again feel free to obviously do some practice So it's just 1 over u, or u to the minus 1. Du by dx. So differentiating u with respect to x, that just goes to 5. Remember think about it as 5 to the 1, 5x to the 1. The power comes down as a multiplier, and the power comes down by 1. So the power comes down as a multiplier, and then the power obviously reduces actually by 1. But obviously, so you obviously have obviously x to 0, but obviously x to 0 at this stage you should know that that's equal to 1. So the answer is just 5. For that, so dy by dx, using the chain rule formula, is dy by du times du by dx. So it's 1 over u times 5, which is going to be 5 over u, and u in this case is equal to 5x. Oops, sorry. So u is equal to 5x. Okay, so you have 5 over 5x, which just simplifies, so cancel down the 5. So cancel the 5s, you get 1 over x. Okay, again, so sorry, for the trigonometry, hopefully you would have got that, so that'll be option number 1, okay? So if you're ever differentiating a function, y is equal, to just natural log of like ax, it will always go to, 1 over x, okay? Unless you have like a multiplier at the front, then it'll be the multiplier divided by x, if that makes sense. Okay, so if it's like y is equal to like 5 log 5x, then it'd be like 5 over x, if that makes sense. If it was like this, let's say, then it would be option number 3. Okay, but obviously it doesn't have the 5 there. Okay. Question number 5, again, obviously jumping some questions here. So the line has the equation 3y minus 4x equals 21. The point P has coordinates 15, 2. Find 5a, so 5 part A. Find the equation of the line perpendicular to L, which passes through P. Okay, so perpendicular, means that, it's the negative reciprocal. So, whatever m is, it will be minus 1 over m. Okay, so rearrange this obviously first of all, in the form y equals mx plus c, or y is equal to mx plus c. So you add 4x to both sides and then divide through by the 3. So you get 21 plus 4x all over 3. Okay. So the gradient of line L, just to be clear here, so that same thing here. So the gradient is actually equal to 4/3. It's the coefficient of x. Okay. So the negative reciprocal here, so it would be minus 3/4. So the perpendicular, so PM here just means like the perpendicular, so it'd be minus 3/4. Okay. And then obviously sub in the coordinates here, so you have y minus y1, so y minus 2 is equal to minus 3/4, bracket x minus x1, okay, x minus x1, x minus 15. Okay, remember, they would obviously be classes, x1 and y1. So remember that formula goes, so y minus y1 is equal to m brackets x minus x1. So rearrange, so times up by 4 on both sides. So I'll do it over here actually. So I've got, actually I'll do it here actually, and then I'll delete it. So times up by 4, so you have 4 lots of everything. So you have 4y, take away 8, so times everything by 4, you get minus 3, bracket x minus 15, so minus 3x plus 45. Add the 3x and then obviously add the 8, okay? But of course, your answer can be in the form, okay, y is equal to mx plus c. But I'm just obviously copying the actual the motto that they obviously put there. So I just thought I'd write it obviously in this form. But you can absolutely write your answer in the form y is equal to mx plus c. If you do that actually, you will get as follows. So you'd get minus 3/4 x, okay, plus 53/4. Okay, so either way, will give you the same answer. Okay, so hopefully it makes sense. Okay, for that. Okay, so part B here is a bit more tricky actually, this one. So it says, hence find the shortest distance from P to L. Okay, so P has the coordinates, okay, 15, 2. And the equation of our line of line L is 3y minus 4x equals 21. Okay, so let's draw like a little picture of this. Okay, so that's our equation there. Okay, so that would be y is equal to 4/3 x plus 7. Okay, so let's do like a little sketch here just to help us out. Okay, So yeah, it's gonna be like a positive. So it looks something like that roughly, yeah, as like a rough guideline. So pass through at the 0.7 there or 0.7. Okay, so I'm guessing, yeah, so point P obviously lies on this line, I think, yeah. So yeah, let's obviously sub it in. So you have 6 take away 60. Okay, yes, so it doesn't actually lie on there, sorry. So 15.2, okay, will be somewhere, I'm guessing, yeah, so like a wild guess here, so it'd be like somewhere here. Roughly, okay, yeah, so again, yeah, it is like a wild guess there, yeah, so 15.2. Okay, and it's wanting like the shortest distance, okay, from there. Okay, so yeah, it's a bit more tricky here. So yeah, it's obviously knowing your points. So it crosses the x-axis, okay, when y is 0. If you solve that, you get 4/3 x is equal to -7. And then divide by 4/3, yeah, so times it by 3/4. Okay, for them. Okay, so that is, yeah, it's a bit more tricky actually, yeah. So shortest distance. So we will have to obviously use our Pythagoras here to obviously work out. But the question that I've got now here is I don't know at the minute here. So in the minute in time here, I don't know like how to actually find actually the actual shortest distance. Okay. Because yeah, it can be there, okay, or it can be there, or it can even be there, like horizontal. Okay, horizontal here obviously sounds logical because diagonal will involve like a triangle. So horizontal will probably be here. So if the y coordinate of this is 2, then I'll have 6 subtract 4x equals 21. And then if I rearrange it, I'll get, yeah, -15 is equal to 4x. Yeah, so add 4x to both sides, yeah, and then obviously -21. So I'll put that there, and I'll put that over here. So you get -15/4 is equal to x. Okay. So that distance there would be, yeah, 2 subtract -15/4. So 15/4, yeah, as a decimal will be what? So it'd be 3 3/4. So it'd be a 3.75. Okay, so yeah, so it'd be 2 plus 3.75. Okay, and that would obviously be your final answer. Yeah, so the answer would be 5.75. And the reason for that is, yes, so I'll come back to what I just said, said actually a second ago, is because any diagonal would have to involve the Pythagoras theorem. Okay, yeah, so any diagonal would obviously form like a triangle. Okay, but if it's horizontal, there is no like vertical, like component. Yeah, if that actually makes sense, yeah, because obviously like a triangle involves, a vertical and like a horizontal actually component. Okay, for that, but because this is just obviously horizontal. Okay, I was like basing it on there, if that makes sense. Okay, unless the vertical is gonna be short, but if I stop in the vertical, then you will get 3y is equal to 81. So y would actually equal 27. Let's use 27. So that will actually be too big. Because you would then obviously have 81 take away 15 next year, which is obviously bigger than 5.75 or 5 3/4. So your final answer, guys, yeah, sorry, your final answer should be 5 3/4. Okay, hopefully, yeah, I've not made a mistake there. Okay, that's my answer for that question. Again, yeah, so it is a bit of like a sticky question, actually, that one. Hopefully it made sense. Okay, that's the end of today's video. Okay, hopefully, yeah, you found it useful. Yeah, those of you doing AS Maths or A-level Maths, if you did find it useful, don't forget to like, don't forget to comment, don't forget to subscribe, and I'll see you all inside the next video. Okay, bye for now. Take care. All the best with your exam revision. Okay, see you soon. Bye.